Hey all, so this is Math 116. It's a review over chapters 0 and 1 for exam 1. There wasn't much in 0.2 that I liked as a test question, so I'll start this in 0.3. And then just a reminder, you should check out the sheet of notes that will come with the exam, because it has stuff like for this section, properties of exponents, the properties that were associated with radicals, and a bunch of that 1.6 stuff. Depending on the quarter, some quarters I might have 1.6 on this test. Sometimes I might have it on the second test, depending on how the calendar lies. So just something to be aware of. So for this first one, we are multiplying, which means we're adding exponents. So we're saying negative 7 plus 3. So that'll be x to the negative fourth. And then remember, it's not simplified until it has positive exponents. So that's going to be 1 over x to the fourth. Number 2 is division, so that's going to be subtraction. So we're going negative 10 minus negative 8. So that would be plus 8, so that makes it negative 2, or 1 over x squared. And then this last one's an example of the property where if we're raising to a power, we multiply. So 6 times negative 3 would make this x to the negative 18, and then 1 over x to the 18th again because of the negative exponent. Okay, more properties of exponents. So this one's a multiply, so that means I'm going to add my exponents. Negative 5 times negative 3, so that will be positive 15. And then x to the third, and then x to the negative 5. So we're going 3 plus negative 5. So that's going to be x to the negative second. And y is to the negative 6 plus negative 1. So that would be more negative, so negative 7. And then I'll just rewrite these to have positive exponents. This one's a division. You don't have to rewrite it, it's just sort of my preference too, so I'm going to. So 6 over 12, we can divide both by 6, and that will leave a 1/2. So I'll go 1/2, and then x to the negative 4 minus 9 is going to make negative 13. Y to the negative 3, there's no y's in the denominator. And then this would be z to the 1 minus 5. And that would make negative 4. And then again, all the exponents are negative. They don't necessarily have to be. They just keep turning out that way in these examples. So they all come downstairs. 3 and z to the 4th. Okay, this is the last one for 0.3. If $P is invested for n years at a rate of I as a decimal compounded annually, the future value that accrues is given by this formula. The interest earned is given by that formula. Find S and I, so find the future value and the interest earned. So P is the principal, so that's 3,000. So that's the money invested. N is the years, so N equals 4. And then I is the rate as a decimal, which was 11%. And so then I could just plug all those in this formula, and then that's going to get me to S. So S equals P, 3,000, and then 1 plus I raised to the N. And so if I clean that up a little bit, I can write it that way. And then I just put all that in a calculator and got S to equal 4554.21. And then to find the interest, I just do how much money I end with minus how much money I begin with, and then that difference would be the interest. So I is going to equal $4,554.21 minus the $3,000. And then that should get 1554.21 equals I. Okay, these next couple are kind of the same thing, except they're in 0.4, and now they'll have fractional exponents. So this will go x to the 4/9, and then minus the 1/2. And then what we want to do is get common denominators. So 9 and 2, nothing in common. All I can do is multiply them by each other. So I'll do 9 over 9 right here, and 2 over 2 right there. And then that's going to get me x to the 8/18 minus 9/18, or x to the negative 1/18. And then another negative exponent, so we'll write it down the denominator. So 1 over x to the 1/18. This one's multiplying, so that means we would add. So it'll be negative 5 plus 7/4. And since this is in terms of fourths, I probably want that in terms of fourths. So when I go 4 over 4, I can think of this as a little invisible 1. And that's going to go x to the negative 20 over 4 plus 7 over 4. So x to the negative, of course it's negative, 13/4. And again, written with a positive exponent. 13/4 down below. Okay, and then this is the root portion of 0.4. So square root, remember it's like we're dividing by a little invisible 2. So square root 25, that would just be 5. And then 2 goes into 11 5 times, so 5x's come out, and 1 stays inside. And then 2 goes into 8 4 times, so there's 4 pairs in there, and for every pair 1 come out, and then nothing left over. This one's a cube root. And so with this one, cube root 80, we're looking for the biggest perfect cube that divides in. So that's going to be 8 times 10 is what we want to think of that cube root as. So cube root of 8 will bring out a 2, and then I'll leave myself some space, and it's going to leave the 10 inside. And then 3 goes into 15 5 times, so I have 5 groups of 3s, that means 5x has come out. And 3 goes into 13 4 times with 1 left over. For this one, I think it would probably be my preference to multiply them together first and then just do the simplify at once. So 10 times 2 is going to give me 20, x to the 4th, x to the 8th, so that's x to the 12th, and then I'll have a y to the 6th. And now 20, looking for the biggest perfect square that divides in, and it's going to be 4 times 5. So square root of 4 is going to bring out a 2. Again, I'll leave myself some space. And then 5 stays inside. Think of the little invisible 2. So 2 goes into 12 6 times. And 2 goes into 6 3 times. Okay, 0.5. So this one you could decide to rewrite or not. I think I will rewrite it. And so then with this minus, I just want to distribute the minus through. So that's going to be minus 6xy cubed. Minus minus makes plus 3xy. And then minus 5x cubed y. And then we'll just match up the like terms. So for x cubes, I have right here and right here, minus 14x cubed y. And then xy, xy, so 8 and 3 makes 11 xy's. And then the y cubes, down 13, down 6 will be down 19xy cubed. And no other like terms, so we can't go any further than that. For this one, it'll be a FOIL. So I would probably do the FOIL part first and then run the 3 through after I'm done. This will make, 3x to the 6th, adding the exponents, minus 5x cubed, minus 4x cubed, and then a plus 20. Collect my like terms. And then run the 3 through afterwards. So 9x to the 6th, 27x cubed, and 60. Okay, so this one I would probably just rewrite as a FOIL. So from the front here we'd have x to the 8th and then y to the 10th. Outside we get minus 3x4 y5. On the inside, exact same thing. That's why the formula has the 2ab in it. And then minus 3 makes plus 9. A couple like terms right there. So x to the 8, y to the 10, minus 6x4 y5, and then plus 9. This one I'll do down here just for space. So remember, this denominator goes with each of these terms. So I'm just going to kind of cancel them one by one. So 32 over 8 would leave 4, and then m fourth and n both cancel out. 8 into 16 is going to be 2. 5 m's up, 4 down, so that would leave me an m. 2 n's up, 1 n down, leaves me an n. And then plus 64 over 8 is 8 And then 6 up, 4 down is going to be m squared, and then same thing with the n. Okay, section 0.6 was factoring. So remember, our first step is always look for greatest common factor. So for this first problem, I can take out a 5x. That's going to leave me x squared minus 8x, and then 5 into 60 is 12. And then you can kind of count on that trinomial factoring further if it was on the test. And this is the kind where it leads with a 1. We've got 3 terms. So we just set up our x's and do what multiplies to be 12, adds to be negative 8. So it sounds like minus 2 and minus 6. This one's got 4 terms, so it's got to be a grouping problem. I cover up those second 2 terms, and I see I have a y in common. So I'll have y out front, 3x plus 5. I know I'm going to get another one of these, so 3x plus 5 again, because I have to match because it's my GCF. And that helps me identify the negative 2 is what I should put here, because negative 2 times 3 gets me back to that negative 6. And then that's our GCF, so it comes out front. And y minus 2 left behind. Okay, so this next one is 3 terms. It does have squares on the ends, so I'm going to treat it as a special product. Remember, we do kind of the square root of both ends, and if this is plus, this is plus. If this is minus, this is minus. And then we can check it by multiplying these two together and doubling it. So 8 times 3 is 24, doubled is the 48. And that's that because of the formula a squared plus 2ab plus b squared. So we have that. And it's always going to factor to that. This one is a squared minus b squared. And so remember that goes a plus b, a minus b. So this one would be 5x plus 6c, and then 5x minus 6c. Number 5, let me come up here with it so I have a little more room. Looks like I can take out a 2 and an x everywhere. So 2x leaves me 6x squared, 19, x in the middle, and then 10 on the end. So then this is the kind that kind of sucks. So it's not the kind with the squares on the end. It's not, and then it doesn't lead with a 1. So this is where you have to do 6 times 10 makes 60. And then we need 2 numbers to multiply to be 60 and add to be 19, which would be 4 and 15. And I do the weird thing where I kind of just repeat that 6, knowing it's about to cancel out. So plus 4 plus 15. And then from here I can divide out 2, from here I can divide out 3, there's that extra 6. And then I just simplify. And if you have a different way of doing this problem, we get the exact same answer, totally good. This just happens to be the one I prefer. Okay, section 0.7 was the one with fractions. So this one's a divide, so that means we want to flip this over. If it was a multiply, we would just leave it, but because it's a divide, we flip it. And then remember, the trick to this is just to factor and then cancel everything you can. So this numerator multiplies to 4, adds to be negative 4. So x minus 2, x minus 2. And then the denominator is multiplies to 6, adds to be 5. So x plus 2, x plus 3. And then I'm going to flip this over, so this is the numerator. So multiplies to 12, adds to 7, x plus 3, and x plus 4. And then this would be downstairs. So that will be x multiplies to negative 8, adds to be 2. So x plus 4 and x minus 2. And then we just cancel everything that's common top and bottom. So x plus 4s are gone, x minus 2s are gone, x plus 3s are gone, and then what's left there would be our answer. Number 2, this is a subtract, so that's a little bit more involved. X plus 5, x minus 5. I'm going to factor the denominator. So x plus 5, x minus 5. And I need to make these the same, so whenever I add or subtract fractions, they have to have a common denominator. So this one would be jealous that that one has an x plus 5. So So we're going to go x plus 5, x plus 5. So up top, that's going to make this x plus 5 times x plus 5. So that will be x squared plus 5x plus 5x plus 25 minus that 100. Oops, 100. All over x plus 5, x minus 5. I can't cancel anything yet because I have to put all this together still. So this will be x squared plus 10x. 25 minus 100, so minus 75. And then x plus 5, x minus 5. Okay, the next step is to see if the numerator factors. And so multiplies negative 75 adds to be positive 10. So that would be, we'll set up our x's, x plus 15, and then x minus 5. Oops. And that's over x plus 5, x minus 5. And then finally I can cancel those out, and then what's left there is the answer. And then that's going to give us 4, and then plus 2x, and then 2 times negative 4 from negative 8 over x, x minus 4. And then collecting up the numerator, I get 2x, 4 minus 8, so minus 4 over x, x minus 4. I could factor a 2 out of there, but it's not going to make this reduce, so I would just stop there. And then this last one for 0.7, this is a complex fraction, and so this is where we use the common denominator to clear the fractions. So we got x squared, and x cubed. So we multiply everything by x cubed. And so this would make 7x cubed over x, so one of those x's would cancel, leaving me 7x squared. Here, x cubed up, x squared down, so that's going to leave me 14x. And then here, x cubed over x, so that's x squared. Here the x cubes cancel, and minus 4. And then this I need to see if it factors, which it does, and then if I can cancel it. So the numerator's got a 7x in common, so that's going to leave me an x minus 2. And downstairs, x plus 2 and x minus 2. And then those reduce. Okay, so the next step is section 1.1. So for this, I would distribute that 2/3 through. So this will be 3x over 4 minus 1/3, 1, and then minus 2/3 x, and minus is going to make plus, and then 2 times 1 will be 2, 3 times 6 will be 18. So now I'm going to look for a common denominator, and that's going to let me clear all the fractions. So for this, 4's and 18, so it's got to be 36. So I'll do 36 here and 36 here. And so this, I can think 4 goes into 36 9 times. 9 times 3 is 27. You can also go 36 times 3 and make that number, and then over 4. I just prefer this way because I can do it in my head. 3 into 36 makes 12. 36 times 1 is 36. 3 into 36 is 12 times 2, 24x. And 18 goes in twice. 2 times 2 would make 4. So now we have this. I would probably collect my like terms first, and then I'll get x's to one side, numbers to the other. So this will be minus 24x plus 40. So I'm going to bring x's over this way, numbers over that way. So plus 24x to both sides, and then plus 12 to both sides. So 51x over here, those drop out, equals 52. So x equals a rather unreassuring yet correct 52/51. Okay, number 2, for that one I'm going to multiply both sides by x minus 2. And that's going to clear the fraction on this side, leaving me 5x plus 3. And over here 7x, and then minus 14. So I'll bring the 7x over this way, so I'll make a minus 2x on this side. I'll bring the 3 over this way, that's going to make a negative 17 on this side. And then divide out the negative 2, and then that double negative becomes positive 17 halves. For number 3, again, I'm going to want to use the LCD to clear the fractions. And so I'm going to factor this. Oops, that's equals 2/3 and then minus 5. I could take a 2 out of there, so 2x plus 5. So that means my LCD is going to be 3 and 2, I would need 6, and then 2x plus 5. So 6 and then 2x plus 5. And same thing over here. I'll just write LCD because I'm out of room. So on this side, the 2x plus 5's cancel, and I have 6 times 2x, so that'll make 12x. Here, 3 goes into 6 twice. And, 3 goes into 6 twice, and 2 times 2 is 4. And then times that 2x plus 5. I feel like I should write that. So it would be 2/3 times 6, 2x plus 5. And then what I'm doing is I'm saying this makes 2, and then 2 times 2 makes that 4. And then on this side, the 2x plus 5's cancel. 2 goes into 6 3 times, and then 3 times 5 is 15. So again, if you can just kind of get rid of the fractions, what's left isn't too bad. So 12x, that'll be a 8x, 4 and 5 for 20, minus 15. I'm going to bring the 8x over, and so that's going to make 4x equals, and then 20 minus 15 would leave 5, and then divide the 4. Okay, number 4, high interest rates make it difficult for people to pay off credit card debts in a reasonable period of time. The interest rate, or the interest I paid on $10,000 over 3 years is given by this formula, where R is the interest rate as a percent. If the credit card interest rate is 18.6%, find the amount of interest paid over 3 years on that $10,000 loan. So I is what we don't know, and I'm just going to copy the rest of this down. And then R is 18.6, and that is as a percent. And then I'll go ahead and subtract this over. And then 18.6 minus this is going to leave 17.937. And then in a calculator, I just multiplied both sides by this. So I go this times this. And that got me we're to the nearest cent. So $3,146.02 in interest. Okay, number 5. A woman making $4,000 per month has her salary reduced by 10% because of sluggish sales. A year later, after dramatic improvement, she's given a 30% raise over a reduced salary. That's the important part, over the reduced salary. Find her salary after the raise. So because the 30% isn't of the 4,000, we can't just take the difference, 20%, and add it on. That won't work. So what we'll do is go 40,000, 10% of that. That would be how much her salary was reduced by. So 4,000 minus, this would be 400, will leave 3,600. So that's her reduced salary. And then she improves her sales and gets a 30% raise over that. So that will be 3,600 plus 3,600 times, what was it, 30%. And then adding those two together, we get 4,680. So that's one way to do it, is just to take and figure out how much, what her pay cut was and then what her raise was. Another way to do it that's actually a lot easier, but maybe a little bit confusing, is if she's making 4,000 and she takes a 10% cut, that means she's still making 90% of what she used to. So that would give us the same 3,600. And here when she gets a 30% raise, she's going to make 100% plus another 30 on top of that. And so I can just put that in the calculator and get that exact same result. What is the percent change from 4,000 per month? So the raise 4,680 minus 4,000 would have left 680 as the raise, and then that over 4,000 returns 0.17 or 17%. Okay, 1.2 is functions, and so a bunch of function notation. So this first one's pretty friendly. We're just going to figure out what f of 5 is and what f of 1 is, and then add those two values together. So 7 minus 5 times 5 plus 5 squared would be f of 5, and then we're adding to that f of 1. So 7 minus 5 times 1 plus 1 squared. So cleaning this up, I got 7 minus 25 plus 25 plus 7 minus 5 plus 1. So those cancel, and I got 7 plus 7 and 1 would be 8 minus 5 would be 3. And so final on that would be 10. Okay, number 2 is a difference quotient. Remember, this is where I put in the x plus h into this function. So it'll look like x plus h squared minus 6, x plus h again, because anywhere there's an x gets an x plus h, plus 2. And then we subtract f of x, and this is f of x, the original. And important to get those parentheses around it. And then that's all divided by h. And then remember, we expand this part out by FOIL, and that's going to come out to x squared plus 2xh plus h squared. And then minus 6x minus 6h plus 2 minus x squared plus 6x, and then minus 2 all over h. And if we did it right, everything that was in the parentheses should cancel. So minus x squared plus 6x minus 6x minus 2 plus 2. And then for what's left, this h should divide into everything. So 2xh plus h squared minus 6x over h. And so here the h would cancel, leaving 2x. Here it would go in once, leaving an h. And there it would cancel, leaving minus 6. These next couple are operations with functions. So this first one, remember, this means the same thing as f of x minus g of x. So it's just saying to subtract these. So 4x plus 5. Anytime we do a minus, we need that parenthesis, x squared plus 4. So 4x plus 5 minus x squared minus 4. And then if I write in descending order, negative x squared plus 4x, and then 5 minus 4b plus 1. The next one's f times g, so we're just going to do 4x plus 5 times x squared plus 4, and then FOIL it out. So that's going to make a 4x cubed, and then on the outside we get 16x, on the inside 5x squared, and on the end 20. And I could rewrite that if I wanted in descending order. Number 4 is a composite, so we're finding f of g of x. So that means that g is going to go into f. So we're literally finding f of x plus 4. We're evaluating f at x plus 4, which is g. So this will be x plus 4 squared plus 3 x plus 4 minus 2. Be careful to FOIL that out. And you should get x squared plus 8x plus 16. Careful not to lose the 8x. And then 3x, and then plus 12 minus 2. And then just collect up like terms. And x squared, that'd be 11x. 16 and 12 would be 28, and then back down, so 26. Okay, 1.3 is linear functions. So give the slope and y-intercept for the following equations. So this one is in point slope form. So I could graph it going when x is 0, y would have to be 4, and when y is 0, x would have to be 5. So x is 0, y is 4, and 5. And then once I get that, then I can read the slope and the y-intercept right off the graph. So this is 5, and this would be negative 4. So negative 4/5. And then b is at 5. The other way I could do it is to bring the 4x over, and then 5y equals negative 4x plus 20, and then divide out the 5 everywhere. And y equals negative 4x, 4/5 x plus 4. Oops, see, I wrote down the wrong one up here. That should be a 4. So either way, we could do that. This next one is write the equation of a line that passes through the given point and has the given slope. So that would be, we're going to go y1, m, and then x minus x1. So plugging in those points, I get y minus 3, and our slope is negative 1/2, and then x minus 2. I'll clear the parentheses. And negative makes positive. 2's cancel, leaving me plus 1. And I just have to move the 3 over. So y equals negative 1/2 x plus 4. And then for graphing, I could make a table, or I could just use the intercept and the slope, which I think I will do. So this one's going to drop 1 and then run 2. So down 1 and over 2. So it should look kind of like that. For number 3, we're not given the slope, but we're given 2 points, so we can do our y2 minus y1 over x2 minus x1. So m equals 1 minus 4 over 2 minus a negative 3. So 1 minus 4, negative 3, and then 5ths. So that's our slope. And then I'll just take one of these points, I'll take the 2, 1, just because it looks slightly easier, and plug into our point slope formula. So y minus 1 equals 3/5, and then x minus 2. I'll run the 3/5 through. Y minus 1 equals negative 3/5 x. Negative and negative will make positive 6/5. And then next I'm going to add this 1 over. And then to get a common denominator, I'll do 5 over 5 right here. So then I have y, that dropped out, negative 3/5 x, and then this would be 6/5 plus 5/5 makes plus 11/5. Okay, 1.5 was solving systems of linear equations. And so we can either do this by substitution or elimination, whichever seems like the better fit for the problem. For this first one, I would definitely do elimination. Just it'd be easy to do a negative 3 or to do a 2 across here. And that would get rid of either the x or y respectively. So I'm going to do the top one by 2 and get 6x plus 8y equals 12. And then I'll add the bottom one to it. And those y's are going to cancel, leaving me 7x equals 21, and then x equals 3. Once I have that, then I can come back to either of these original equations. So 3 minus 8y equals 9. So negative 8y equals 6. And then y equals negative 6/8, also known as 3/4. I reduce my fraction. So my solution here was 3 and then negative 3/4. For number 2, that one's already solved for y, so that kind of makes me want to do a substitution. So what I'm going to do is I'm going to take this piece right here and put it in for that y right there. So that'll look like 1.2x minus 0.2 times that stuff equals 3. And then I'll just distribute that decimal through 1.2x. This is going to give me negative 1.2x, and minus minus is going to give me plus, and that will be 3 equals 3. And here the x's drop out, leaving me 3 equals 3. So this one would be dependent. And then number 3, looks like if I multiply the top one by 3, that should work pretty well, because I'll get negative 6 plus 6, plus a bit more. So negative 6x, and then 3 times 5 would be 15y, and equals negative 3. Add this one to it. This side, everything cancels, so I'm left with 0 equals negative 3. So that one is a no solution. Okay, so this next one is a 3-equation, 3 unknown. So remember, our strategy here is to put 2 equations together, eliminate a variable, put 2 different equations together, and then eliminate the same variable. So I happen to go with y's in the notes. I think I'll do that again. So I'm going to go equation 1 and equation 2, add them together, and that's going to go minus y plus y. Okay, so then adding, I get 3x, those drop out, and then plus z equals 2. So for me, that's my equation 4. And then I'll probably do, I'm going to do negative 2 times equation 1, and then add that to equation 2. So negative 2x minus and minus make a plus 2y, which is what I needed, minus, that's 4z and positive 6. And then adding these together, I get x, y's drop out, minus 2z equals 3. So for me, that's my equation 5. And then I think I'll get rid of z, so I'm going to go 2 times equation 4. So that would be 6x plus 2z equals 4. And I'll add 5 to that. And that gets me 7x equals 7, or x equals 1. Once I have the first one, I can back solve to either 4 or 5. So 1 minus 2z equals 3, minus 2z equals 2, and z equals negative 1. And then once I have these two, I can come back to either 1, 2, or 3. So 1 minus y plus 2 times negative 1 equals negative 3. So negative y, so this would be 1 minus 2, so that's minus 1 equals negative 3. Add the 1 over, and negative y equals negative 2, so y equals 2. So solution set is 1, 2, and negative 1. Okay, and lastly, 1.6. Again, depending on the quarter, sometimes I put this with the first test, sometimes I put it with the second exam. And so if I've covered this in class, it's on the test. If I haven't covered this in class, it's not on the test. It would go on exam 2. So for question 1, we have suppose the ceiling fan manufacturer has a total cost of that, total revenue of that. What is the equation for the profit function for this commodity? So this stuff is another thing that would be on those sheets of notes that would go with the exam, is kind of a reminder of all these different definitions. And so remember, profit is revenue minus cost. So we'll say P of X is going to equal R of X minus C of X. And again, anytime you write a minus, you need that parenthesis if there's more than one thing coming. And then collecting that, I get 58x. No, I don't. I get 58 minus 30 is 28x. And then minus the 1400. What's the profit on 30 units? So if I plug 30 in here and find P of 30, that will be 28 times 30 minus 1400. And then tossing that in a calculator, you'll get negative 560. And so that means that we lost money when we only made 30 units. So how many fans must be sold to avoid losing money? So that's when the profit would be 0, right? Because we're not losing money, we're not making money. So that's like our break even. So 0 equals 28x minus 1400. Add that over. 1400 equals 28x. And then divide the 28. And I got x equals 50. Okay, for the second one, we have company charging its profits. Notice a relationship between the number of units sold, x, and the profit, p. So that means we're going to be writing this as x comma p. And that's linear. For 170 units results in this much money, turn 20 units results in that much money. Write the profit function. So they're giving us these ordered pairs. So it's just going to be finding the equation of a line using these 2 points. Helps me if I write them out so I don't get things backwards. And then this is 220 and so finding our slope, go y2 minus y1 over x2 minus x1. And up top, that got me 2,900. And then downstairs, that would be 50. So that gave me a slope of 58. And I just did this with the point slope formula. So p minus, I think I used the smaller numbers, yep, equals slope 58 times, x minus 170. And then distributing and bringing this over, p minus 2360 equals 58x, and then 58 times 170 comes out to negative 860, and then just add that over. So then p equals 58x, and that comes out to minus 7,500. So that would be their profit function. And then find the marginal profit. Remember, marginal anything is just the slope of the function. So if it's marginal revenue, it's the slope of the revenue function. So here, marginal profit would equal 58. Okay, number 3, a manufacturer sells belts for $13 per unit. The fixed cost is $900 per month, and the variable cost is $10 per unit. Find R of x, C of x, and P of x. Okay, so R of x is going to be x times the amount that they sell them for, so $13 for each unit they sell. C of x, that's going to be the fixed costs and the variable costs. So variable cost is the per unit, so it'll be $10 for every unit, and then the fixed cost, remember, that's what we have to pay regardless of whether we sell any or not, so it's stuff like rent. And then for the profit equation, we can just do P of x equals R of x minus C of x. So P of x will equal 13x minus this stuff. And so that's going to be 13 minus 10 will be 3x, and then minus 900. And then find the break-even point. So I can either set these to 0 and solve, or I could just set this to 0 and solve. So I'm just going to set the profit to 0. And then dividing over, I get x equals 300 units. Okay, so question number 4 goes, a company distributed college logo sweatshirts and sells them for $45 each. The total cost function is linear, and the total cost for 60 sweatshirts is this much, whereas the total cost for 250 sweatshirts is that much. Find an equation for the revenue. Okay, so they sold them for $45 each. So our revenue function is going to be R of x equals 45x. Write an equation for the total cost function. So this is where we have to use the ordered pairs. And so what we want is we want x to be the number of sweatshirts, and we want y to be the cost of producing them. So that's going to be 60 and 2904 for our first pair, and 250 and 49.94 for our second ordered pair. And then we're back to finding the equation of a line, so I'll go ahead and find the slope. And so y2 minus y1 over x2 minus x1. And then cleaning that up, it ends up being 11. And then what I could do from there is use the slope in one of these points to find the actual equation. So our cost is going to be c minus c1, so I'm going to use the smaller number, equals m, which was 11, and then x minus x1. And then cleaning this up gets us our cost function. So that'll be 11x, and that'll be minus 660. And then bringing this over, I get cost as a function of x is 11x plus 2240. And then find the break-even quantity. So that's going to be where revenue equals cost. So I can go 45x equals this. And then subtract the 11 over. And then I get 34x equals 2244. And then divide. And I got x to be 66 for the break-even quantity. Okay, number 5, if the demand for a pair of shoes is given by this equation and the supply function is this, compare the quantity demanded and the quantity supplied when the price is 90. So remember, this is where we're going to put in the price and then see how many people would buy the shoes at that price, and then see how many pairs of shoes they'd be willing to manufacture for that price. So for the demand, that was the first equation. So 2 times 90 is our price, and then we'll figure out what quantity goes with that. So 5q equals, this will be 180, bring that over, and it makes 320, and then divide the 5, and that makes the quantity 64. So at $90, 64 pair are demanded. And then we'll do the same thing with the supply function. So for $90 minus 2q equals 20, bring this over and get negative 70, and q equals 35. So that means the manufacturer is willing to supply 35 pair at that price. So will it be a surplus or a shortage? More people would buy the shoes than they're willing to manufacture, so that means there's going to be a shortfall. And number 6, find the market equilibrium point for the following demand supply functions. So basically all we're doing there is solving for where these two lines would intersect. So we're just solving a system of equations. I'm going to bring this q over to this side and write this as 2p plus q equals 75. And then it matches up nice with that minus q right there. So 3p, minus q equals 65. Adding those together, I get 5p, q's drop out, and that's 130, 140. And then dividing, I get p equals 28. And once I have that, I can plug it back into either of these and get the quantity. So 2 times 28 equals negative q plus 75. And so that's 56 equals negative q plus 75. And I'll bring that over. Negative 19 equals negative q, so q is 19.